So hello everyone, my name is Rahul Bollini. So today I'll be talking about what's inside a cell and what's happening in the market, specifically to the Indian market. So let's begin. So there are two types of integration. One is forward integration and then there is backward integration. So forward integration basically means going from a mining company all the way to manufacturing battery pack. So this is what the forward integration looks like. And the companies, popular companies who are doing that, Ganfeng Lithium, many companies in India already testing Ganfeng Lithium, and REPT is a fairly new company who are into nickel mining. So their cells are also just started beginning to come to India, and these are the cells. Backward integration is, battery pack to mine. So popularly Tesla and LG, that is their focus. Tesla recently got into the lithium mining process, and they're also exploring other metals. LG has been making cathode for quite some time, and they are exploring how they can go to the backward integration. And this is their battery pack, how it looks like, Tesla's battery pack and LG's battery pack. And this is the complete chain of raw material to cell to module plus BMS to a pack and pack to an electric vehicle. Let's talk about cathode active material manufacturing. So generally when people talk about lithium ion cells, all the cells are named after the cathode chemistry, say LFP, NMC, NCA, LCO. So all that is the cathode active material that's inside the cells. So firstly, there is a co-precipitation method which is involved to make a precursor cathode active material. And so basically you can work with sulfate. So there are various ways how to do that. You can take the carbonate route, there is a sulfate route, there's also acetate route, but generally the market preference is working with the sulfate route. And you can go to a precursor level, and then precursor plus lithium compound would help you go to the cathode material, which is the CAM. So their calcination method is used where for many hours you are heating it up to close to 1000 degrees Celsius, and it is done at a multi-stage. And especially when you're dealing with high nickel or nickel rich cathodes, you will have to do it as much as 3 times, and that increases the cost of the energy, and hence these materials are expensive. It's a very common question. People ask me that cobalt content is decreasing in NCA or NMC 811 compared to NMC 622. Then why are they expensive? So I tell them you have to study the calcination method, how these cathodes are prepared. Then there you get the answer. And yeah, so basically when you're working with the formulation, so you either get brines or ores. So brines is what you see in Argentina, Bolivia, Chile, the golden triangle that they call. And then there are ores in Zimbabwe and Australia. Australia is the biggest mining country as of today, the production base. So when you take the brine, you can easily convert it into carbonate. And if you really want hydroxide, then you have to reconvert it into hydroxide, lithium hydroxide. And if you take the ore, you can directly make it into hydroxide. So hydroxide is highly preferred for making electrolyte. So let me show you the example. Yeah. So here is the formulation of electrolyte. There are many ways how to make electrolyte, but this is the most preferred, how the biggest companies in China do it. And coming back to NMC, basically you can take the sulfate, which is the most preferred, cobalt sulfate plus nickel sulfate. There's either EMD or it could be manganese sulfate. EMD stands for electrolytic manganese dioxide. And then you reach the NMC precam. So in this, the ratio of cobalt sulfate, nickel sulfate, and the manganese material, that will decide what kind of precam you achieve. So if you want to achieve 111, so you'll have to use a different ratio compared to achieving 532. And depending on the NMC that you want to make. So NMC 811 uses a different route. NMC 532 and 622 uses a different route in terms of the compound of lithium used. So lithium hydroxide is more popular in NMC 811. Carbonates are more popular in achieving NMC, lower NMCs such as 622 and 532. Hydroxide tends to give a better stability and it has a lower temperature point. It's simply better to work with. But again, the consistency of lithium hydroxide is a very big challenge from mine to mine. And in the same mine also, getting that kind of consistency is a very big challenge. That's why many people prefer working with carbonates. That's why carbonates are highly preferred in LFP. So this is the LFP formulation. Basically, you take the carbonate from the brine, and there is iron oxide plus phosphoric acid, and which will actually help you achieve iron phosphate, which is also called as FP. And then there's a different plant where you add lithium carbonate to FP to achieve the LFP cathode. LFP cathode is pretty much the same formula where you get it in the market. It's all made in China with a specific capacity of about 160 to 165 mAh per gram. There's not much innovation happening at the LFP cathode material because it's almost a 20-year-old material with a saturation point. That's where people are looking at the futuristic materials, such as incorporating a little bit of manganese in it. So many new companies are focusing. In fact, CATL has made some samples and shipped to Tesla for validation. So that is happening. And this is the alkylate formulation. So basically, this helps you achieve LiPF6, and that is the base salt for pretty much all the alkylates out there. And that base salt is put into various solvents. Basically, the first solvent is EC, ethylene carbonate, and then there are various other solvents you can work with. There is DEC, DMC, EMC, and the ratios are important, additives are important, and the weight is to volume ratio of the additives that you're adding, not more than 2% generally. So all that formulation, so alkylate is an art by itself, and I'll talk about it in the future slides. So availability of raw materials in India, this is something people keep asking me because I have spent enough time in the country looking at all these aspects. So I always say that cathode, basically this is all kind of cathode you'll be hearing about. Today's cathode, yesterday's cathode, and future cathode. If you see carefully, it is pretty much some metals are evolving, which is there's a lithium, there is cobalt, there's manganese, there is nickel, then this kind of materials, and then there is phosphate based materials, iron phosphate or manganese phosphate. So these are all pretty much the 5-6 materials that you'll be seeing. So I have written a complete detailed article about it a few months ago. So I'll share that link in the chat box also. So these are all the links that I have shared here, as well as I will post it in the chat box also. Just a minute. Okay, I'll share it in there. So coming back to anode, graphite is a preferred thing, and there is two types. There's natural and synthetic. This is preferred for the reasons that synthetic is preferred for the reason that it has slightly higher life because it's an engineered graphite. And then there is alkylate, which I was talking about, the whole thing where the LiPF6 base salt is put into solvents and additives are added. And then there is separator, which is also a very interesting topic, which not many people talk about. Separator can make or break your battery. Separator will decide how fast your cell will short circuit, because separator is the thing which separates your cathode and anode from short circuiting. And this is probably the most ignored topic. And I have written a detailed article about it. That link is also there, and I'll be sharing in the end of the thing. And then these are all the other materials. There's conductive carbon, pretty much imported from the West countries. They have a slight domination in it. And today, mass manufacturing is happening there. So there is a company in Switzerland, there's an American company, they are dominating. Then there is non-aqueous binder, which is pretty much the PVDF. PVDF also, the Belgium companies are very popular. Not one, there are two. And then there is aqueous binders, which is pretty much can be localized. So when people ask me what are the things that can be localized, I have made a list in the future slides. But yes, CMC can be localized, not a problem. SBR is basically a type of rubber, also can be localized, not a problem. PVDF is an engineered thing. It sounds easy, but it can be challenging. There are two types. There is suspension based, and then there is emulsion based. So some people like emulsion, some people like suspension. So they have their own choices, and depending on that, people go to the companies. And there's also a Chinese variant of it, much cheaper. The big companies use the imported ones, and then there is, the Chinese equivalent, which are used by the mid and the smaller ones. So I would say that if India plans to make PVDF initially, for them to match the standard of this imported will be slightly difficult. But eventually, I think with scale and with the maturity being picking up and all, so I think that might not be a problem. NMP is fairly already manufactured in India in a very big way. It is exported to US also. I was talking to some company who are exporting to pharma industries. So NMP localizing in India, no big issue. And anyways, NMP is recycled. In fact, BASF can recycle up to 99.9% of the NMP used. Others are close to 99. But yeah, that gives you a chance to actually reuse. And NMP is not environment friendly. You have to use a heavy mask so that you don't breathe. Because if you're breathing it on a regular basis, it can be highly poisonous. Deionized water, there's a water filter where you can just run through the water and it'll deionize it. So localizing is not a big deal. Current collectors, there's aluminum and copper. So aluminum pretty much easy, copper not so easy, because copper tends to be very, very thin. I have seen personally all the way to 4 microns in high energy density cells, and making 4 microns with electro deposition can be really, really challenging. But yes, it can be done, but the capex is going to be huge. Tabs are fairly easy to be made. Aluminum and copper coated with nickel, not a big deal, can be done. And then there is a case. So there are 3 type of cases. One is the SS with the nickel coating. So that is basically for the cylindrical can. And then there's a pouch which has 3 layers. The top layer is PP, and then there's aluminum foil, and the bottom has a resin. So that is the pouch cell. And it can be easily cut and flexible to make any kind of cell dimension, not a problem. In-house, you can fabricate any kind of design of the cell with very high flexibility. And then there is an aluminum prismatic can, which are the large block of cells that you saw initially from Ganfeng and REPT. Yeah. So India leaning towards LFP. So just before the webinar beginning, I was talking to the recycling guys also. LFP, it is going to be, for the simple reason it's cheaper, it lasts longer, it is safer, and it can work in higher temperatures. And India does not lean towards the colder temperatures, although we have some states, some places. LFP has a drawback. It cannot charge easily below 0 degrees Celsius. But there's a solution to it where you attach some heaters and you bring up the temperature to be able to do. But that's going to waste some energy and going to increase your charging time. So LMFP is a new kind of LFP, which, like I told, Tesla, CATL, the big guys are talking about, soon to come in the market. Yeah. So lithium production reserves, you can see clearly there's nothing in India. People are telling there's something in Karnataka and all, but very small quantities. And today, although the production and all is happening, but all of them tend to end up in China, where all the processing is happening, because China has invested in the cathode manufacturing, China has invested in the pre-cathode manufacturing, and they have also invested in the sulfate manufacturing. So all the way, so when people talk about backward integration, forward integration, I always give example of China, that you should go and see what's happening in China. We need to replicate that kind of integration to be able to be self-sufficient in future. So coming to phosphate, phosphate, India has less than 1%, and it's very popular in the fertilizer industry. It's already being sold at a premium, and but Morocco is the leader in that. So considering that, I told LFP has iron oxide, phosphoric acid, and the lithium carbonate. Phosphate needs to be discussed because phosphoric acid needs to be made. And iron ore production, no doubt India has all the iron we need. In fact, we can export also, not a big deal. Odisha has great amount. And iron oxide, like I told, is essential for LFP cathode manufacturing as well as LMFP also. Manganese production, we have quite, but we still tend to import, especially South Africa and Gabon being leaders in that. So tomorrow, when we are shifting to LMFP, manganese might be a little bit challenged, because I have seen how the roadmap of all these big gigafactories are. So there's LFP, then there is high energy density LFP with a silicon graphite anode, and then they tend to shift towards LMFP. So eventually manganese has to come, that's the way it is. And it gives you a higher energy density, roughly say 8 to 10% in terms of volumetric and gravimetric. Yeah. Graphite availability, India is in the top 10, I think 8th or 9th. And the challenge that the global market is facing today is graphite has been completely ignored. Cobalt, people try to overproduce. Nickel, the Russia-Ukraine war, there was a high price, and then they were able to absorb the volumes available and all. But graphite is something which is completely overlooked. That's exactly where I think India can win, because we have competent graphite manufacturing companies. In fact, there are, I was told, 8 companies who are doing very good volumes. So I think that is something where we can immediately jump onto the wagon and start supplying. And it's not as difficult or as patent protected as it is for NMC and LFP. In fact, the reason why LFP, nobody was able to manufacture cathode, LFP cathode outside China is because it was patented until this year. And that's why China was given a free hand and they were able to do that. In fact, Japan, Korea, there are companies. SK Innovation is a big fan of LFP. They wanted to make LFP, but they were holding on until 23 and later. And now that the patent is open, almost open, I think India can also be in that early birds, and the other countries jumping into it. Yeah, and graphite availability, not a problem. Aluminum, we are the second largest aluminum producer. We have huge bauxite mines, again Odisha and the other places. And the thin aluminum foil is necessary. Generally 10 to 16 microns is the range which people are looking at. I was talking to one Kolkata based company. They were telling they imported some machines where they can achieve close to 5 microns. So I'm seeing good enthusiasm in the industry and people are looking at it. And aluminum tab is used as a positive terminal, which is pretty much thicker than that. So that should not be a problem. That is 100 microns or higher. Yeah. Copper availability in India. So copper, there was a time when India was self-sufficient, and then because of the growing demands, it went slightly below, and then we had to start importing. So copper, again, you need, like I told earlier, you need close to 4 microns in the highest of the energy density, and that is electro deposited copper foil, which can be very expensive to set up. And I am not seeing very active participants in India as of today, because I'm sure they're aware that it can be expensive to set up. Aluminum, I'm seeing a few. Separator also, electrolyte also. I'm seeing everything, but copper foil is something I'm kind of missing the link. Maybe I'll have to check up again. Yeah. So copper tab with nickel coating is used as a negative terminal. And this thickness decides the C rating of the cell, because this is the tab which will actually be transferring electrons and working with the discharge. So if you are looking for a high C rate cell discharge cell, you should ensure that this tab is actually thick. So one cannot know the thickness of this tab unless it's a pouch cell. Inside a prismatic or a cylindrical, you cannot really see. That's where sometimes I tend to do a CT scan of the cell just to look at the thickness of it to understand. Because for the sake of telling, people can tell that it can work at any kind of C rating, no problem. But the efficiency of the tab to pass on that kind of current, because every square mm of copper used, there is a current carrying capacity. So you cannot expect copper to be used in minimum quantities and expect unlimited current. Say, for example, the best of the copper cannot give you more than 6 amps per square mm, the best of the copper. So if someone claims, I will give you 60 amps of discharge continuous and the copper is not 10 square mm, then it's going to be a challenge. There's going to be a lot of heat built up, and even we can expect fires also if it's NMC and NCA batteries. So coming back to the challenges, lithium-ion cell manufacturing, as you are aware, it's yet to take off in a big way. And nobody is really coming in 23 in a big way. Giga is not, maybe mega plants are planned. Giga, you can only see from 24 onwards. 3-4 big companies are planning in a big way. And today, the market, we are seeing a lot of announcements from Europe, US and all. There are some in US and all that, but they're not really operating with a full capacity utilization factor. They're not really price competitive. Even in their own country, companies are willing to work with China and all that, for the pure reasons that China has a lot of gigafactories. And India can also do that, like I said, but we need to be self-sufficient with all the 15 raw materials that I spoke about earlier. And since China is the biggest manufacturer, China is also the biggest consumer of raw materials that go for cell manufacturing. And they tend to work with the domestic suppliers, and then the remaining ones are exported to Korea, Japan, if depending on the arrangement. And here I see that LFP cathode, like I told earlier, LFP cathode is all manufactured in China, most of them. So there's a Belgium company also that I was discussing with long back, but the job contract, it happens in China. So they have some patents and all that some kind of things, but when it comes to manufacturing, China. So Then there is a global market, which is, I see that not just for the, so when the Indian companies will take off, the raw material companies will take off in India, I see that they should not be working only with Indian companies also, because Indian companies are a little bit slow in taking off, but there's a global market available for some of the materials, not all of the materials, because like I said, nobody's looking at copper, electrodeposited copper right away. So that might not be open. So, but yeah, PVDF, like I told, the Belgians are really good in making PVDF. Not one, like I told, two companies are there. So that kind of grade, I think we can catch on. Even China imports from them. Conductive carbon, like I told, there's a Swiss company, there's an American company. I think we can catch up that. No, that should not be a problem. And electrolyte is something which is always advised. So whenever people are working towards cell manufacturing, any technology partner advises that you try to procure your electrolyte locally, because it's highly sensitive for air and water and even the sunlight. That's why the way it is packed, it looks very, very secure. So generally, initially people start with importing the LiPF6 salt and then putting the solvents and additives here. But eventually, I think even the salts can also be made here if you go towards the backward integration using hydroxide and all. Yeah. So circular economy, I think Utkarsh will be talking more about it, but just a general, there is a battery, the consumer is not happy with the range of it, and then they want to replace it. Then there's a two-way of checking it. If the battery is fit to be reused or no. If it cannot be reused, it goes for recycling. If it can be reused, then it is studied properly and then again sent for a reuse and then properly monitored with a good IoT device or something, so that its failure can be known. And once it fails, it goes to the recycling plant. And then you get you recover the metals and all. So let me talk about the battery failure analysis. This is the first staging and the second. So second is not as linear as the first one, like I told. And there's a lithium ion recycling. I'm sure Utkarsh and Gaurav will be talking more about it. But yeah, earlier the intention was to recover the metals and then put them in the sulfuric acid and achieve the sulfates. Now it is to get the sulfates as directly as possible. And the future is looking towards getting the precam and the carbonates and hydroxide directly, so that it's much simplified. So types of battery recycling, there is hydro, pyro, and hydro is more preferred because it's more green, uses less energy and all that. So I think, yeah, that will be all from my side. Any questions from the audience?
Thank you, Rahul. Thank you for that very informative presentation, and of course sharing insights from your own on-ground practical experiences in the field. We had highly appreciated. So yes, there are a lot of questions coming, and I would again request all the audience members to please use the Q&A box to put your questions in the chat. It becomes very difficult to track the questions for the speakers as well. So that's a humble request. So Rahul, there are a lot of questions if you look at the Q&A box, but I'm afraid we won't be able to have any time for the verbal Q&A right now. We need to move to Utkarsh's presentation, especially given that he has a flight to catch after this. But we will allocate around 20 minutes.
I've shared my links, all the 4 links.
Yes. Okay, on the chat? Yes, that I can see. Thank you for that.
The 4 major components.
Yes, thank you. We've got it. So we will, Rahul will move on to Utkarsh's presentation now, and we will have some around 20 minutes for the Q&A towards the end. In the meantime, you have the option to respond on chat, respond to the Q&A, the questions on the Q&A box by typing in your responses. So let me welcome Mr. Utkarsh Singh, CEO at Batex Energies, and he will be presenting on the importance of recycling, specifically in the Indian context, in strengthening India's battery value chain. Over to you, Utkarsh.
Thank you so much, Prakshi, and thank you for bringing us all together on one platform. Sorry, my flight timing kind of collided with today's event, so I have to bring it in top. Okay, so I'm gonna give a very practical scenario what's happening in the Indian context, and where starting from the consumer to OEMs, where everybody has to become cautious now, given the shortage of materials at the moment for enabling India to produce, its own lithium ion cells, like very well explained by Mr. Rahul, that what is going to be the context of India and approach towards the development of the cell. But at the same time, I would also like to add on, no matter wherever in the world, even if the materials are available in the mines, we need to reduce the stress that we are creating on the earth by mining these materials. So more and more that we are going to recycle and take our approach towards a circular battery material supply chain, it will be better for the future generations. So therefore, that is given that context, we as a company have taken an initiative where, given the requirement of the materials that is increasing all over the world, it becomes very important to recycle these materials. Moving ahead, the main four problems that are arising with the increase of electric mobility all over the world is, first, the average life cycle of a battery pack is kind of 3 years to 5 years. Given the context of two-wheelers and three-wheelers, it is around 3 years. And for electric four-wheelers that are available in Indian market, companies are giving it around 5 to 7 years. So what happens? The life cycle, once it reaches to its end of life cycle, then customer has to get it changed. So what happens? Either you go, if it is electric four-wheeler, you will go to a particular authorized dealer where the battery packs will be taken out. But the problem is, these battery packs will be huge, around 35 kilowatt hour to 40 kilowatt hour batteries that will be coming in Indian vehicles. So it will be very difficult to, transport these batteries all over the places, because it will be around 450 to 500 kgs of one, battery pack. Wherein we talk about electric three-wheeler and two-wheeler battery pack. So electric two-wheeler battery pack somewhere varies around, 20 kgs, and electric three-wheeler is around 50 kgs. So the volume that has started coming in for three-wheeler and two-wheeler has started coming in from this year onwards. Wherein the trend that we are seeing for the battery waste that is coming in India from 2020, by the end of 2022 and the starting of 23, a lot of two-wheeler and three-wheeler battery packs have started coming back, wherein the certain thing that we have realized, the cells that are coming back from two-wheeler battery packs and from good brand OEMs are ready for second life. So they can be reused for another life, wherein we recommend that, all these stationary storage applications that are available in the market, they should go for second life battery packs instead of first life battery packs, because we believe second life battery packs can also function as good as first life battery pack. Wherein if we talk about the electric four-wheeler battery packs, so we have not seen many battery packs coming back because we are also not able to source them from the market. But I think by the end of 25 or starting of 25, the battery packs will start coming back. So far, only all the accidental case, four-wheeler battery packs and all are coming back in the market. But wherein right now the Indian battery recycling market is driven is by the electronic, application batteries that are coming. On an average, last year, India produced around 25,000 metric ton of battery waste, which we were able to calculate given various sources, out of which 25,000 metric tons of battery waste, or only about 5,000 metric tons of waste was recycled. That too, recycling was in a way wherein it just reached to certain recyclers in India. So therefore, there is a huge, opportunity that lies in India. Would like to share that, a lot of our clients who are from abroad, they all are, pushing hard to us that we should partner them for Indian market, because they believe that India is going to, being huge on population, we are going to produce a lot of battery waste, which is a resource for all of us, given the critical materials that go inside it, that is lithium, cobalt, and nickel. Yes, LFP battery packs is something that recyclers are afraid of. But as also Rahul explained in his presentation at the end, that there's a direct recycling method that is also available, the technology, can also be worked around. So that is where, recyclers like us are more focused for LFP to go for direct recycling, wherein for chemistries like NMC, NCA, LCO, we are doing hydrometallurgy at the moment. Now, the second part is the extensive mining. So we also have to be careful with the increase of electric mobility. Yes, we all are saying that electric mobility is a cleaner way and a cleaner approach to automotive industry. But we have to make sure that the materials that we are mining, the way it is done in various parts of the world, is creating a lot of stress. For example, to mine, lithium, there's a huge water stress that is happening in countries like Argentina, Chile, and Australia, wherein the way the cobalt is mined. I've also added a picture here that it is creating a lot of human hazard in the states of Congo. At the same time, for India, speaking from the perspective of India, like we were dependent for fossil fuel on various countries, that should not be the case when it comes to lithium ion cell manufacturing or clean mobility in India. So therefore, whatever material is being imported or whatever cells are being imported in India shall be recycled, and that is what even the government's approach is. Government in India is very bullish on the circularity and a cleaner approach towards producing these materials. Now, to just give you some numbers, in last 2 years, India has imported a lot of lithium, which is somewhere around 62 million tons of lithium that has been imported, and wherein in 2021, because of COVID, of course, the graph has gone down. But I think India has been a big importer for lithium. But at the same time, because of certain shortage in the market that has come in because of the electric mobility, now India is failing to import lithium for various applications in India, that is pharmaceutical industry and other industries. So therefore, there's a huge opportunity for us as recyclers to circulate back the materials back into Indian ecosystem. Yeah. So going forward, what approach we take towards recycling, that is, we focus on various sources from where this scrap is generated. So right now, I mean, you will be shocked to know that you also have around 3 grams to 4 grams of lithium with you in your mobile phones, or around 6 grams of cobalt with you, given the chemistry. So electronic sector, yes, right now is biggest, from where we are sourcing at the moment. We also tie up directly with the OEMs, wherein so there are two kinds of market segments in India. One is unorganized and one is organized. So in the scrap market, even we have learned over the time that, unorganized market in India kind of dominates. But that is where this entire industry has started, and companies like us, LICO, are kind of pioneers in this. So we are trying to organize this market, wherein the majority of scrap, which is the electronic battery scrap, is coming from the unorganized market. So we, tie up with a lot of waste aggregators all over the country. But at the same time, we are tying up with the OEMs, where we are also helping OEMs to give them a diagnosis data, that what went wrong with these batteries and how they can even improve the quality or the life cycle of the battery. So that is what a part of the solution that OEMs like. So I think data is also going to play a big role when it comes to recycling. That is a hidden gem in the process, because if you see at the Chinese recycling system, so the companies there, or the cell or by battery pack manufacturing companies, uses BMS, which captures the entire life cycle and the cell performance, or the module performance over the years. And the recycling companies actually leverage that data, and the battery pack companies leverage that data to make, to enhance their performance of battery packs. So that is also a responsibility with the recyclers. This is just not a recycling game. It also has a lot of technology that is being involved on all three fronts. That is on the chemical front, for the extraction of material, on the IT front for, taking out the data and properly analyzing it. And then also on the electronics front to make sure that when you're recycling these huge battery packs, you're doing it in a proper way and with the most safest way. So wherein, once battery packs come to our facility, we run them through a series of tests. The first being where we test the capacities and the performance of the cell. Basis that we, segregate these cells. If they're in good quality, we send them for second life applications. In case they are not, then basis that we take them for our material extraction facility, where these are extracted from in all the different salts of these metals, that is lithium, cobalt, and nickel, given the requirement of the customer. Wherein we work with different customers of the world. So everybody has different kind of requirements. So right now, I think this industry is new, and we are also in the phase where customers are changing their requirements of different salts of these material. So I think within a year's time, it will come to a stage where the requirement of the customers will also be stable, and we will be producing that in bulk. This is kind of our products that a recycler is, or company like us is producing. The most famous being the black mass. That is what a lot of recyclers are producing in India. So and even in the black mass, it comes down to the quality and the content that is needed in the content of cobalt, nickel, or lithium that goes inside black mass. India, being right now, is the one of the largest producers of black mass, and that we are doing at the moment. But I think this year, 2023, we are going to see recyclers, pivoting from the black mass production to the extraction of these salts. So I think that is where once these salts start producing in India, I think a lot of cell manufacturers who are planning big way in India will be interested to tie up with a lot of recyclers. And then that is how the material is going to be circulated. But until then, whatever produce is coming from the recycling is exported at the moment from Indian market. Here are some snapshots of how we are doing and running our tests at our research center at Batex. And this is how our, at the moment, black mass production plant looks like. So it is a series of mechanical process, and the plant has been developed in-house by us. At the end, I would just like to sum it up by saying, see, if we look at the clean technologies, mining is something that is not in our hand because that is a natural resource, wherein lithium is the metal of the decade, and it is going to stay for some time. That's what we believe. For other chemistries, different combinations and compositions can change, but lithium is one of the most stable metal that will be there in the any energy storage application. Wherein nickel, different countries are producing nickel. Indonesia is planning a big way in that. Because we met one of the Indonesian delegate, and he shared about their plans for Indonesia for nickel, wherein Indonesia is looking at to come up to the finished product, not just selling the ore. Wherein cobalt is done in DRC. So all of this material, finally reaches to countries like China, where it is processed and made, battery grade ready at different countries. So that is where India also has a capability, and I mean, India is developing its capability and has a chance and an opportunity to produce, battery grade materials. But that is where, all of the different systems of the entire value chain has to work together, be it the cell manufacturer, be it the recycler, be it the, EV OEM. So all have to work together, then only it becomes a possibility, but definitely India has a chance. So that's on that point, we as a company is contributing in Indian ecosystem for circularity. So thank you.
Thank you so much, Utkarsh. Excellent presentation, I must say. And good to know about your own operations. And I know that recently you were speaking at G20. So congratulations on that, and good luck and have a safe flight. Please feel free to leave the webinar if you when you have to.
you so much.
So if you have some time, there are a few questions addressed to you in the Q&A box. If you have
Sure,
some time
sure.
for your flight, please
I
ask.
think I will be just answering to all the questions.
Okay.
Thank you.
Wonderful.
Thank you.
Okay, so let me invite next Mr. Preetesh Singh from Nomura Research Institute. So Mr. Preetesh will be talking about an overview of India's current position with respect to battery value chain and which Indian companies are leading the charge. And so let me just invite Mr. Preetesh to share his screen.
Thank you very much, Priyakshi. Please let me know if my screen is visible.
Yes, Preetesh, if you can go to presentation mode, please.
Is it okay?
We are not in present. Yes, now it's okay. Yes.
Okay. Thank you very much, Priyakshi, for the opportunity to talk about the lithium-ion cell supply chain, assessing India's capabilities. During the presentation today, I plan to cover 3 chapters mainly. First chapter about electric vehicle market in India, then a little bit about demand of LIBs from automotive and ESS applications. Then moving on, I'll talk about current battery supply chain in India, which includes battery and pack manufacturing status, cell manufacturing and PLI scheme, cell component manufacturing, and eventually I'll conclude with the raw material scenarios. Several points have already been covered by Rahul and Utkarsh. So I'll keep skipping some of the contents which are common in the presentations. Moving on to the electric vehicle market globally, if you look at the numbers, so the global electric car market has been increasing more than 50% in last 7 years. Obviously dominated by China, followed by Europe and then US. China has the largest EV fleet with 7.8 million cars, followed by Europe with 2.3 million, and then United States with 2 million cars. Let's have a look on the situation in India. So if you compare the numbers from 2018 to 2022, there has been significant jump in last 2 years. So if you compare the number from 2020 to 2022, it has been growing with the CAGR of 188%, more than that. And if you just compare last 2 years number, it has grown more than 200%. So that is a fantastic growth which India has achieved. And with this level of growth, the debate whether EVs are going to happen in a big way in India or not, I think has no place now. So it is obvious that India is moving towards electrification. So let's also talk about a little bit about different vehicle segments. On the two-wheeler segment, initially the two-wheeler market was completely driven by startup companies, but with time, non-traditional players are also entering into the game. Similar is the case for the three-wheelers. Now you can see majority of the traditional and the non-traditional players in the three-vehicle segment. Initially, the market was dominated by mostly e-rickshaw segment, but now you have a lot of vehicle sales from the L5 segment also. Moving on the passenger vehicle status in India, I think passenger vehicle or the passenger cars took some time to come up with the products other than Tata and Mahindra. But now, if you see all kind of vehicle manufacturers, you will find in coming into the electric car segment. Those who are not present, within a year, you will see the product introductions mainly because of the CAFE norm introduction, and also with the CAFE norms, heavy penalties are being imposed with the cap of 25,000 per car and 50,000 per car if you miss out the targets. And so one thing has been very common across the segments, that initially the product quality was not so good, but in all vehicle segment now you will see better quality products coming on year by year. So if you compare the batteries, motors, inverters, initially the low specifications were there, but now the specs, battery sizes are improving, and with time they will keep improving. That also in the end will solve the challenges of probably for recyclers also, because ultimately we are going to come up on some particular kind of battery chemistry, which Rahul has also talked about in the beginning. It is important to understand what kind of vehicle segments are going to grow in future, and also what are the reasons behind that. So if you look at the electric two-wheelers, currently electric two-wheelers are mostly growing because of the applications such as food delivery, e-commerce goods delivery, hyperlocal grocery delivery, and personal commercial commute. In future, you will see other introduction of other applications such as racing bikes, etc. Electric three-wheeler has different use cases, and they will continue growing with the those kind of similar applications. In passenger cars, in four-wheelers, you will see currently there are passenger taxi for intracities mostly, and the personal commute. But in future, the mostly it is going to shift towards passenger taxi, intercity, intracity also, and then racing cars, off-road cars, caravans, etc. are going to be introduced. In e-buses and truck segment, it's currently mostly goods delivery with the e-commerce companies and the public transportation. But in future, several other applications might also emerge, such as public transportation, intercity and state, and school and college buses. These are some of the applications. Obviously, there will be several other applications also in future. Now moving on to the demand of lithium-ion batteries from automotive and ESS applications. Globally, the demand has been growing very fast, and the demand is mostly for the passenger EVs. If you look at the India situation and talk about Indian battery demand estimated numbers, so in Indian estimated numbers, you will see this is an aggressive scenario, probably a little bit of challenging to achieve these numbers, but yes, this is the kind of aggressive case which we can consider, and mostly dominated by stationary storage, grid scale, followed by electrification, which includes mix of vehicle. And in this case, if we take such case, then the battery demand is expected to rise to around 230 gigawatt hour by 2030. And currently, we do not have even any gigafactory. So there is a huge potential demand and huge possibility of the lithium-ion battery manufacturing in India. Several battery chemistry options, which other speakers have already talked. But what I would like to communicate here is that the current applications which are there, current battery technologies like LFP, NCA, LMO, several are there. But in future, you will also see phasing out of some of them and introduction of different battery chemistries. Obviously, different battery chemistries for different applications. But if you look at only for passenger cars, so in our opinion, it is mostly going to be NMC and LFP. And in several vehicle segments like buses and cars, it is mostly going to be the LFP chemistry. Why so? Let's have a look on the current battery supply chain in India. So it is a natural progression that we start from pack manufacturing and then we eventually end up to the cell manufacturing components. But in this progression, currently we are mostly into the pack manufacturing status. You can see the different kind of companies, categorizing different kind of companies. The purpose is to understand what efforts at what level and in what direction Indian organizations are doing in the lithium-ion battery manufacturing. So we have companies like Ola, Reliance, and Rajesh Export, which have been awarded under PLI scheme. Then we have traditional battery manufacturers, which have a very good understanding how automotive industry works. And also probably they have much better experience working with the automotive OEMs. So their experience is also going to work a lot. So their presence is inevitable in lithium-ion battery manufacturing. Then we have non-traditional players also, such as Mahindra, L&T, India Power, Thermax, Tata Chemicals. There are others also, and also there are startup companies. So there are a mix of companies mostly exploring the pack manufacturing currently, and in future they plan to have cell manufacturing. Let's have a look on the challenges of a, let's say, passenger car OEM. What are the challenges they are facing with the current level of supply of the batteries? So if you look at the current supply of batteries, mostly challenges are in terms of very high cost of batteries, inflexibility with the battery design, safety and cost of the transportation, also delaying in providing services, government policy and localization push. That has to be addressed. So automotive OEMs in India are not only depending on the battery manufacturers, but they themselves also plan to be somehow to be present in this entire battery value chain. For example, some of the OEMs with the vehicle manufacturing, they also want to be present probably in the cell manufacturing with a JV with a company. Why this is extremely important for automotive OEMs in India is that first time, I think in last several years, the battery prices have gone up, and mainly because of the increasing raw material prices. So in order to have a control on the demand, they need to be present around all parts of the value chain. Then, so that is how the cell manufacturing from all angles becomes very important in India. And there has been a very important initiative. We are all aware about that, PLI for ACC applications with a huge amount of budget. And it is a fast-tracked program also. And eventually we have 3 players with the Hyundai, with the removal of Hyundai Global Motors, because they were probably not able to meet some of the criteria. So now we have Rajesh Exports, we have Ola and Reliance. Other than PLI for ACC, government is also planning for the PLI for niche chemistries, wherein you will see introduction of different other battery chemistries, maybe not in that level of a scale, but for niche applications, there can be other battery chemistries also. Some of the collaborations like C4V has a collaboration with OSM, and OSM is bringing the C4V technology in India with the semi-solid state batteries, which they have. There are other organizations also pitching as part of the PLI for niche applications. Now moving on, if you look at the plans, the plans which are disclosed by these companies, for example, Ola Electric has been working on the capacity building of 1 gigawatt-hour in 2023, then moving to 20 gigawatt-hour in 26 and 27, and in very long future, they also think about 50 gigawatt-hour battery plant. And such companies are better placed because they have a captive demand, so they can meet their two-wheeler captive demand, and in future, if they come up with their passenger cars, they can meet passenger car battery demand also from their in-house factory. And obviously, they are open for other OEMs for across the vehicle segment. If you look at the plan, I'm talking about the companies which are part of the PLI scheme. So Reliance has also won the bid, and they have collaborated with 2 companies, Lithium Rex and Faradium. Lithium Rex with LFP chemistry. So you will see a lot of LFP chemistry batteries going into their automotive applications. And then Faradium is sodium-ion battery for future applications. Let's also talk about their LFP battery component. So there is a difference between NMC and LFP in terms of their cell cathode constitution. And if you compare both the chemistries, LFP chemistry is quite favorable for India because of the low constituents of the cell cathode and also high possibility of manufacturing. On fundamentally or theoretically, 69 to 90% of the value can be captured for LFP in India, but for NMC, it goes only around 43% theoretically. So LFP basically here also is kind of a winner in terms of the value addition, and value addition is important because 60% of the value add criteria under the PLI scheme. Moving on, cell component manufacturing. I'll take some time and explain about the need of localizing the downstream supply chain. So if you break down the vehicle into different cell into different parts, so you have assembly, you have materials, you have cell manufacturing. So around materials constitute around 40% in general about a vehicle, about a battery. And mostly currently India has very limited presence around any kind of material. But if India targets to achieve 60% of the value add, then we need to localize anode, cathode, electrolyte, and separator at least. For anode, there are several companies like Epsilon, Mitsubishi Chemical, Himadri, HEG, and it seems that India is a better placed in terms of anode manufacturing. There are some initiatives in cathode also, like Alox and Epsilon. And then in electrolyte, we have companies GFL, Neogen, and in separators, we have Dynamic. Let me have a look on the anode manufacturing status in India. So how these companies are basically trying to capture the anode manufacturing market. So first target is approval from global battery manufacturers, because currently there is not much demand in Indian battery companies. So they look at potential anode manufacturers, look at to get the material approved from global players such as Panasonic and LG first. Becoming a supplier of such players definitely gives a very good advantage and acceptability to all kind of battery manufacturers. As global players enter in different geographies, they can also enter together with them and try to capture the other markets. Second point is exports to lead demand. Anode manufacturers in India are making plans for manufacturing based on not Indian scenario, but the global scenario. Domestic demand for local cell manufacturing companies is expected to take at least 3 to 4 years in India. So that is how supplying and having a very good experience globally is going to add a lot of value. Then Indian anode manufacturers are favorable because preference of non-Chinese suppliers. So this is the thought process of Indian anode manufacturers for Indian market. So I'll now talk about some company initiatives. For example, in anode, Epsilon is one company which has been very aggressive. And if you look at, they produce mesocoke, which is a precursor to anode material on a commercial scale of 2,500 TPA capacity. Pilot facility to manufacture synthetic and natural graphite. If you look at their future plans, by 2030, they plan to have capacities around 100,000 million ton of the synthetic anode and 50,000 million ton of natural graphite. Similar plans you can see for Himadri Chemicals also. And in future, they plan to produce around 20,000 MT by 2022 and to produce 100,000 million ton of anode material by 2028, obviously in a phased manner. Now I will move to the cathode manufacturing. Any, be it anode, cathode, separator, electrolyte, generally they look at two things mainly. One, security in terms of demand, and also proximity to the natural resources. Somehow, unfortunately, India doesn't places very well on those two criteria. So India's specific challenges are lack of clarity on demand, lack of government push and schemes, lack of technical expertise, availability of raw materials. These are the key challenges what a downstream vendor for any kind of material is facing, especially for the cathode manufacturing. But yes, at the same time, there are companies like Alox who can be one of the potential or the future players who have announced the manufacturing of cathode materials. And in future, if you look at the current situation, they enhance the imported material into LFP cathode through a patented process, and then current cathode manufacturing capacity of 50 kilogram per day. But if you look at the future, they plan to go into commercial production by 2023, end of the 2023, and increasing the production capacity also 10 to 15 tons per day. Moving on, separator manufacturing. I have one example of Dynamic, and in future, they plan to start a greenfield project for manufacturing lithium-ion battery separator, and when the demand increases. They're a Asahi Kasai group company and have aggressive plans also for separator manufacturing in India. Then Neogen also has a plan, and they basically plan to scale plant for electrolyte and lithium salt production for captive consumption to be set up later, not now. And and GFL also have very aggressive plans. I think we are all aware about the initiative, so I'll skip this. And moving on, I will cover raw material scenario in India. I think majority of us are aware about it because Rahul and Utkarsh both covered this topic. So I'll briefly touch upon it. Cobalt, nickel, aluminum, lithium are majority of the components which goes into the lithium-ion battery. And if you compare the NMC, because we concluded on LFP and NMC chemistry. So on LFP and NMC chemistry, you have lithium, nickel, cobalt, and manganese. And India somehow only present into the nickel raw material, not in lithium and cobalt and manganese. So that's a very big challenge for us. The reuse of batteries and very strong ecosystem of recyclers is going to play a significant role, a very vital role in the electrification journey of the country. Because if you compare, the demand role of different materials like lithium, cobalt, and nickel, EV demand is going to surpass, I think, other applications. So it's really very important to think about the circularity and start not only taking, making and using, but also reusing and recycling and closing the loop. As Utkarsh was mentioning, that India has very limited capability in terms of metal production. It's all dominated by China. Wherever they are not into the metal production, they have gone ahead and captured entire value chain of the metal processing. But that's also one of a big opportunity for India, wherein we can try and build capability. So because company to company collaborations are not going to help such capability building. So there is a huge requirement of having G2G collaborations, and NALCO, MECL, and organizations have basically come up with a very good plan. And it's like something similar model of ONGC Videsh. So India has set up a joint venture company, Khanij Videsh India, and that has been created by Ministry of Mines. So that is a very good plan. And other plans also are from NMDC. So once these G2G collaborations picks up, India is going to solve majorly such challenges. So these are my thoughts, Priyakshi. Thank you very much. And I would like to thank my team who contributed in making this presentation. Thank you very much.
Thank you, Preetesh. Thank you so much for that insightful presentation. We'll now move on to the next presentation by Mr. Srivastava from Ensure Reliable Power Solutions. And like I mentioned during the introduction, that Ensure is venturing into lithium-ion cell manufacturing, and Mr. Srivastava will be sharing the perspective of a cell maker and updates about what their company has achieved so far and what their near future plans are. Over to you, Mr. Srivastava. You can please start your talk. You are on mute, sir. Yeah.
Very good afternoon. Now, am I audible now?
Yes, we can hear you.
Okay, very good afternoon to all the panelists over here. And thanks, Priyakshi and Akshay, for coordinating this effort to bring to give a bit of overview to the excited audience, and I think a very healthy audience of around 250 people are there. Yes, it was very nice presentation right from Mr. Preetesh, Gaurav. Not Gaurav is yet to come up. I think Utkarsh and Rahul. So we have seen the what India stands and what will be the demand down the line in the next bandwidth of 7 to 8 years. Everybody is talking about the projection of the market on the demand side and what are the challenges India stands as far as on the lithium cell manufacturing and the demand side on the application. So very well narrated and presented by all of them. I appreciate it's a very thoughtful insight, and some are very quite deep insights they have given. As far as Ensure, I would like to we would have seen the names. India Power was our lead partner through which we have participated in ACC PLI scheme. Okay, fortunately, unfortunately, we were not the part of the people who got qualified. We were all holded on the wait list. And as Preetesh clearly narrated that Hyundai, because there were 4 people who got, Hyundai for some reason has to back out. So it's between Reliance, Ola, and banking. So we have to see who is going to get that. Ensure, yes, is a company which is the parent company. You can move the slide to the next one. So Ensure Reliable Power was a spun-off company. The parent company is Ramalingam Construction. They have a background of almost 30 plus years, 3 decades of infra projects in urban sector. And it was incorporated in 2016, 6 years back, Ensure. And Ensure was spun off with the initiative to probe the opportunity in the energy sector. So 6 years back, I think this was the first private entity which has executed commission on this modality of DBFOT, where we have executed close to 1 lakh of prepaid smart meters in Bangalore utility, BESCOM, which is more known from them. And we have similar project done in Mysore also with SESCOM. So now the smart meters are coming big way in the mainstream. So now from further diversifying in energy sector, 2 years back, this idea of with our MD, Mr. Chandrakant, we thought of forging ahead in the energy sector. That's how the idea of getting into the lithium cell manufacturing came up. So the last 1.5 years has been more contemplating the chemistry, the demand on the application side, the format, and the technology partner, land. So, you know, the project is very capex intensive. So we had been contemplating for 1.5 years. Finally, we decided, as everyone has been voicing it, India is a pro LFP market. And Rahul and all, why LFP will be the core chemistry down the line in the various application and Indian domain is concerned. So Ramalingam Construction, as you can see, they are into various slum terrace project, irrigation project, electricity distribution, marine structures, and civil construction for 30 plus years. Next slide, please. I take some time to move the slide, Priyakshi.
I have moved it. I'm on RCCPL client.
So, okay. So they have a good clientele base. Yeah. It is spread across the domain of Indian scenario. You can see various state, various agency, government departments, and they have got a very healthy turnover. Pardon, Priyakshi?
It's moving. I think there's
having some network issue. It is getting
looks like a lag, but we can continue, sir. We are on financial slide right now. I hope you can see the same.
Yeah. So, okay, this is the parent company. We have a net worth of $52 million and Ensure the baby of RCCL. So we are yet to take off. Establishing now as far as the roadmap of Ensure. So this was just to give you the brief idea about the parent company, the backdrop of the company Ensure. You can move to the next slide, Priyakshi. I think some internet is not stable. I'm sorry for that, gentlemen. Yeah. So as everyone was trying to showcase the global market, so I think on the demand side, this is what the 3 terawatt hour we have been talking about collectively of stationary and e-mobility put together by 2030. And we can see that obviously 80% will be the demand coming from the automobile, which is e-mobility. Micro-mobility, which is mostly as far as India is concerned. So from current 200, close to 200 gigawatt hour, the market is poised to grow by almost 25%, 250 times, which is a great one. Now, as far as India domain is concerned, we know that we are driven by electric mobility, and within that electric mobility, our mainstay will be electric two-wheelers and three-wheelers, and various data and statistics for the last 1 year, which my previous panelist, I think,
Sir, you may try switching off your camera.
we
there's
create a
bandwidth
big
issue.
opportunity. Is the voice breaking?
Yes, the voice is breaking in between. Looks like a bandwidth issue.
Just hold on. I switch to the just be on the line. Sorry, General, I just switch over the Wi-Fi so that it is a little bit better.
Okay, sure.
I hope now it should be much better now.
Sure, we'll let you know if it goes out again.
Yeah. So, so now I don't know, some internet is a big issue here. Am I audible, Priyakshi?
Yes, sir, we can hear you. Please carry on.
Okay, sorry, gentlemen. I think sorry for the Wi-Fi interruption over here. Now, ensure after all the thought provocation, we have done a lot of contemplation during the last 1.5 years. As I said, finally, we decided to set up over the first gigawatt hour, and we may be one among those who will be coming, as Rahul also told, by 2024, we can see at least 2-3 gigawatt hour coming up in India by 24. So this is the roadmap everybody is seeing, and we all are eagerly looking forward to, and we may be one of those first few to take off the pedestal to start manufacturing and delivering lithium cell manufacturing indigenized, made in India. So we have decided to go for LFP, and purposefully we're seeing the demand side. Our focus on the low-hanging market, which we see is electric two-wheeler and three-wheeler. For that, we have decided to go for pouch, though it's a kind of a new format for Indian market as for now. But we see down the line, as we have spoken to so many stakeholders, right from the top line, big ticket pack manufacturer, that swapping model will come a big way. And pouch, given the format and given the advantage on the thermal and stability as well as compaction ratio on the pack manufacturing, will give a little bit edge against the LFP cylindrical and prismatic. Prismatic, for that matter, except three-wheeler, two-wheeler is hard to get into. Everybody who are into the pack manufacturing understand that prismatic, we don't have much of very low volumetric density compared to what can be achieved by pouch and cylindrical. And cylindrical, since globally today options are very, very little except 32700, we know we lose a lot of space when we go into the pack level. So we have decided to go for two basic models, LFP pouch 30H, because 30H is a core model on the energy side when we see right from a low speed 48 volt 30 to 60 volt 30 in the mid speed, and then high speed also 70 to 30. So at least 30 can be a core model. And we all understand that one model or any format cannot serve across the spectrum of application, but we have to take a call what will be the best in the immediate future on the demand side. So that's what 30H was decided to go for pouch. We have also chosen the upcoming new model on the cylindrical. Can you change the slide, Priyakshina? It's not moving because I'm sorry. I had a struggle initially to log into the webinar. So I have logged in from a different laptop. So my presentation, I asked Priyakshi to share.
Can you see the prelude activity slide?
Yeah. Now it is gone. So just to understand the market in the last 1.5 years, Ensure also took a shot at bringing the cells from same Chinese importer manufacturers, and just to feed the market, to be in the alignment with the market, to be with the market, to understand the requirement and how the demand of various form factor goes and the various chemistry. So that's how idea was to import all 18650, 32700 pouch and prismatic, which we have, but our focus was very clearly to bring the quality cells, and we focused only for the EV grade, or what we call very popular word EV grade, from Chinese manufacturer. All the leading one, whether it is Huazing, Avitech, Ganfeng, CATL, Highstar, whichever Indian market has evolved all these years using all those brands, Jam, DMGC, EVE. So all kind of those cells which are used purposely in electric two-wheeler and three-wheeler, we are trying to import and feed the market. So we have acquired close to, next slide please, we have acquired close to 150 plus clientele base as of now, which constitutes of all the low end and the mid range and the big ticket battery pack manufacturers. We have generated around 75 CR plus in the last 1 year of bringing this cell and feeding to the market. And but obviously now, since we want to go ahead this year, definitely by the time factory will be up and running. So the first phase of manufacturing, as far as Ensure is concerned, it will be the R&D lab and pilot lab, which should take off by August, and by early 2024, the main plant should be start getting commissioned. So I think by, if thing doesn't go fall out due to unprecedented situation, I think by, so these are the testing equipment which we are testing the cell for before giving to the customer. Next slide, please. So as far as manufacturing side is concerned, as I shared, first phase will be by August, September, we'll be having our R&D and pilot up and running. And by early next year, maybe first half before that, we'll be having our main plant 1 gigawatt hour, which will be having a two-part catering to pouch and a cylindrical on the assembly line. And next slide, please, Priyakshi. So as far as the investments are concerned, we are seeing close to $100 million in this first phase to set up this 1 gigawatt hour, and that kind of investment is going to take up, and the time bandwidth of investment is up to 2025. And then we have a roadmap to further, once this plant achieves a load factor of 80%, we'll be going for expansion of further 2 gigawatt hour, and then another 2 gigawatt hour by 2028 or 29. So this is a roadmap of 5 gigawatt hour, which Ensure has as of now. And as I shared, again to reinstate that the first model to come up is next one. The first model which will be coming LFP pouch, and another model with 33140 cylindrical LFP with 15 Ah capacity. So these are the two model. Ensure will be, we have our technology partner in place. Already we have made a full advance discussion with them. I think plant and machinery, everything has been finalized. And in maybe another couple of months, Ensure will be placing the order for the main plant of 1 gigawatt hour. And hopefully, if everything goes well in time without much of deviation. I think Ensure should start production of LFP cell in India by August or September 2024. So this is our roadmap as I shared. Again, I'm reinstating through the slides. You can see that. Next one. Actually, you can go to the next slide also. So we will be open to all kind of feedback from the market. I think our choice of chemistry and the format, which we have fine-tuned with so many discussion, with so many meetings with the stakeholders. So this is 160 acres of land back we have taken up in near Bangalore itself. There the first plant will be coming up. Next slide, please. So I'll share you what the two models which we decided firmly, little bit of spec sheet of that, the general technical parameters. For interest sake, people can have a look at it. So as I said, this is all like what brief from Ensure on their roadmap. And by 2028, we are also working with technology partner to bring, as somebody showed, the technology roadmap. So yes, 200 watt hour in LFP. We will be working, maybe if thing goes well in our R&D, maybe in a couple of years, we'll be able to test bed that LFMP cell in LFP to match the voltage of NMC and safety aspect of LFP and the better cycle life of LFP. So this is the roadmap as far as Ensure for the first 5 years is concerned for setting up the Ensure lithium cell manufacturing of Indian market. So this is the first model, 15Ah LFP cylindrical. And this is one model which has the highest volume density in any given format of LFP as of now. So this surprisingly, this model should be an ideal model for, as I said, making a 2P of 30H using in the battery pack. And it can serve a good option along with the pouch cell. So that's the purpose of choosing this two model as of now. Next one, you can show the pouch cell also.
One slide back, I think.
Yeah, one slide back before that.
This is the pouch cell slide.
No, before that it was cylindrical. Before that there is a pouch.
Yeah, number 14.
Yeah, this one. Yeah. So this is the pouch cell, which is approximately 11 mm by 133 by 202. So it is close to 175 watt hour energy, specific energy, volume density of 325. So that's all. Priyakshu, thanks a lot for allowing us to present ourselves, our roadmap of manufacturing as far as Ensure is concerned on lithium cell manufacturing. We are open to any question, any feedback, suggestion from the very august audience over here. And as far as possible, we'll try to address them.
Sure. Thank you so much.
Thank you, Priyakshu. Thanks a lot. Yeah.
Thank you. Thank you so much. Yes, I can see a couple of questions for you in the chat.
Yeah, I will try to answer them there.
Yes, and we wish you the very best for your plans with cell manufacturing. I think the all of Indian energy automotive ecosystem is eagerly waiting for domestic cells to come out in the market. So we really hope we get there soon.
Thank you, Priyakshu. Thanks everyone for the patience listening, and sorry for that unwanted disturbance due to unstable Wi-Fi.
No worries, sir. Now we'll move to Mr. Gaurav Dolwani's presentation. and he will be presenting on LICO's capabilities and their approach to lithium-ion recycling.
Hi, good afternoon, everyone. Let me just share my presentation. Yeah, I hope you can see this.
Yes, but can we go in presentation mode? It's opening like a PDF. Or maybe you can just, in case it's not enlarged, you can enlarge the screen.
Yeah, I think it's better.
Yes, that's better.
So LICO is a lithium-ion battery recycling company. We're based in Mumbai, and I'll just go through the presentation for the same. So, as I said, we're a recycling company with a focus to create a sustainable circular economy solution in the lithium-ion battery supply chain for recovery of critical metals such as lithium, cobalt, manganese, and nickel, to given back to battery manufacturers to give the materials a second life. As Utkarsh spoke earlier, I think we work very similarly. We both are battery recycling companies, so you must have understood a bit from what he said. We are purely, in the lithium-ion recycling space. We do not recycle other kind of batteries like lead acid, etc., because there were some questions that were asked. So the idea of the company is to recover every single fraction of any critical metals that are available from waste batteries and put them back into the battery manufacturing supply chain towards closing the loop. Essentially, this is what it looks like, a material movement chart. This is how we, once we have battery waste, it will be procured. It comes back to our facility in Mumbai. We store the same, and then there's sorting. We stack them in different piles based on the chemistries. If it requires dismantling, such as EV batteries, we do the same. They are then discharged so that there is no voltage remaining when we process them. Then we recycle them. And once our finished goods are passed through quality, we dispatch them. Basically, when you go through recycling, you will arrive at something called black mass, which is a black powder, which is a combination of anode and cathode. So regarding our technology, the team at LICO has developed its own technology for recycling lithium-ion batteries. We have achieved an industry-high yield due to optimum efficiencies and constant upgradation in our technology. In our technology at the moment, we are using only the mechanical process, which is shredding, crushing, grinding cells, and then further separation of different materials through vibration, gravity, density, and air separation, so that you arrive at black mass, plastic, copper foils, and aluminum foils. There is a pre-process to this where there is discharging, where we discharge cells in a solution so that we are able to reduce the voltage completely before they go into a mechanical process, so that we avoid any kind of fires. If we are talking about electric vehicle batteries or high voltage batteries, we do an electrical discharge before we do a deep discharge. After we complete the mechanical process, there is, as I said, we are working on processes such as hydrometallurgy and direct recycling technologies. We are in discussions with established recyclers in USA and Europe that have successfully commissioned commercial scale plants. We have also been in touch with a number of professors who have technologies in very esteemed universities in India, but which are still based at lab level, and we are trying to see how we can commercialize the same on a larger scale. So currently, in the world, there are three major options for recovery of battery grade minerals from spent batteries after the mechanical process. The first one is pyrometallurgy, which includes very high temperatures and through fire. The problem that we see in this is that there's, it's a very high energy consumption. It's not very eco-friendly because of CO2 emissions. And the biggest challenge here is that there's a loss of lithium. In hydrometallurgy, basically, which is acid leaching, and how you get through different stages of different kinds of acid, concentrations and timelines, you're able to retrieve each of those metals independently. However, doing it at lab scale is very different. And when you are handling it at a larger stage, with 5,000, 10,000 metric tons per annum, when we're looking at, handling these kind of acids, it's extremely challenging because you have a lot of, questions on how you're going to handle these acids. How will you dispose of these acids? So it's something that we are constantly working on. Our R&D team is doing the same, and we're trying to figure out what is the best method for us. Also, what we see is in hydrometallurgy today, most recyclers are not able to recover battery grade salts from used batteries. Battery grade salts means their purity needs to be 99.9%, which is still a challenge and not yet achieved globally. The third option is direct recycling. We spoke about it a little bit earlier as well. At this stage, this is a very early concept, and it's not fully commercial yet, but it is a promising concept, and it involves not breaking down the cell completely and going back to destroying the chemistry between it and then rebuilding it. As I said, these are early days, so we are still exploring how we could work on the same. These are typical metal recovery rates that you would see through the different methods that I just explained: pyro versus pyro, hydro, and mechanical pyro, and then direct as well. So you can see the recovery of the different important minerals like lithium, nickel, cobalt, copper, etc. And based on this, most recyclers have chosen one or the other path. But I think that this is something that is constantly evolving, and it's something that you may need to adjust for different chemistries as well. Currently, the black mass recovered in India is getting exported. And this is due to us being in a very nascent stage of cell manufacturing. Once cell manufacturing commission their plants in India, the ecosystem around it will get built, and then we will be able to reuse those cells and those batteries within the country. As of now, as you know, they just spoke before me saying that we are 2.5 years away from cell from the PLI scheme awardees as well as independent cell manufacturers. Once those cell manufacturers end up setting up in India, and around them there would be anode and cathode precursor companies, as they mentioned, the gentleman from Nomura said, companies like Epsilon. What would happen is that a recycler like ourselves would be able to take end-of-life batteries and do a mechanical process followed by a recovery process, and then we would be able to give it to somebody who would be making anode and cathode precursor, who in turn would be giving that to a cell manufacturer to make a new cell and put it back into our ecosystem. So in an ideal world for a recycler, we would like to supply the recovered minerals to a company that makes the precursor, thus closing the loop and being part of the circular economy. Challenges with collection and process. So raw material today comes from three sectors mainly: personal devices, energy storage, and mobility. Personal device batteries such as mobile phone batteries, laptop batteries, etc. are bought in from the informal sector. Most of these raw materials still lies in our homes due to reluctance of recycle of e-waste. The informal sector is very unique to South Asia because nowhere else in the world do we have something called a kabadiwala. Today, for us to procure personal device batteries, we need to work with a bit of informal, which I just mentioned are the kabadiwalas, but also e-waste aggregators and e-waste collectors. We work with a combination of them and try and get us the raw material we need, which is currently available in India. The challenge with working with the informal sector is always one of lack of consistency, lack of transparency, lack of reliability. And this is a big challenge for any recycler in India today. You never know what you're going to get, how much you're going to get, and at what price you're going to get. Generally, in the rest of the world, people pay recyclers to take away material to recycle, but in India it works the other way around. I think that is something that will take time for people to understand and come to terms with. Because as a recycler, you can only afford to pay you what you can recycle. So the second point of where we could get our raw material from is energy storage batteries, things like power grids, solar grids, backups. They all use energy storage, mobile phone towers. So we have, LICO has agreements with 8 different companies which make energy storage batteries at the moment. We collect their batteries and issue the necessary certification, which is EPR compliance, as per the new battery waste management rules that were released last year for recycling. And then the third and the most prominent one that we read a lot about these days is mobility or electric vehicle batteries. Although it's still at a very early stage, we have supply agreements with 14 different companies with manufacturer EV batteries. We collect the batteries and issue the necessary certification, again, as per the EPR guidelines. This is a typical image of what a 2-wheeler or a 4-wheeler battery would look like. And the 4-wheeler or bus batteries would be high voltage, whereas the 2- and 3-wheeler would be a bit more compact and handleable and can be handled pretty easily. So at the moment in our facility, we would have batteries from 2-wheeler, 3-wheeler, bus and car. Of course, we haven't reached end of life for many of the bus and car yet, but we still have been able to get some that are through R&D testing, and we are able to do our own R&D on the same. In our opinion, the largest challenge that we are going to face in India is going to be the transportation and the reverse logistics for these batteries. The transportation of end-of-life batteries continue to be a huge challenge, with the informal sector and third-party sector providers taking zero safety precautions, which may lead to fires and fatalities. It's something that we take very seriously, because we have also seen in the West that there are safe ways of transporting lithium-ion batteries. And I think every recycler here wants to do the same. And, you know, I don't think anybody sets out to be unsafe, but it all boils down to how commercially viable it is. Because when we talk to OEMs and we talk to battery pack manufacturers, etc., it depends on how seriously they take safety. Because of course there's a cost attached to it. And if we're going to look at only what is the cheapest cost and moving it by third-party logistics, we are always going to compromise on safety. So we use logistics partners that have necessary firefighting equipment in their vehicles, and the drivers are trained to use them too. We also have pan-India logistics and warehousing partners for collection and safe storage of lithium-ion batteries. We are committed to the highest level of safe practices when it comes to reverse logistics by using transport boxes that are certified for safe transport of lithium-ion batteries. If we look at the current and future global battery supply chain, it looks a bit like this. Today, we are at maybe 300 to 400,000 megawatt hours. And I think by 2035, we are looking at about 4.5 million, which is almost a 15x demand from where we are today. And if you see the graph, you can see that the main driver for this is transportation. So mobility has a huge role to play in the natural resources that we will need. And what can a recycler do to plug that gap? So if you see, this is just one of the metals that you would use, which is nickel. So by 2035, you're looking at about 7 million tons of nickel. And the capacities that we have today, plus the planned capacities in mining, also probable capacities, we're still way short of what we will actually need in 2035. Even if you look at the light blue color, which is essentially what will come from recyclers, we are still 1 million tons in deficit. So there's a huge opportunity for recyclers to provide that gap, to make sure that we can recycle what is considered waste or garbage and give it back into the supply chain. This will reduce import dependency for our country, and we'll be able to keep using the raw material that we have in our country again and again and again. Various studies have showed that the quality of any of these batteries or minerals do not degrade by second life. In fact, some studies show that they perform even better than virgin material. So my request would be, please open your cupboards, open your drawers, take out all those old phones and laptops you have. Please give it to an authorized e-waste collector. Let it go back into the recycling economy so that we can make new batteries from this and reduce, import dependency. Currently, India has none of the minerals that we're talking about that go into a battery. We do not have lithium or cobalt or nickel. And it's essential that we take recycling as a serious partner in making sure that we bridging the gap between our demand and supply in the next few years. The current plan and future roadmap for LICO. Currently, we operate a 3,000 metric ton per annum capacity plant in Navi Mumbai. We're in negotiation with a few states for breaking ground for a second facility, which will have a similar capacity of 3,000 metric tons per annum. This facility will be ready to operate in 12 months. In the next 5 years, we plan on having 5 such plants throughout India with a hub at least one of those locations where we will be able to recover battery grade minerals, the capacity of which will be 10,000 metric tons per annum as planned, and we hope that we can open it next year. Thank you very much. I'll be open for any questions that you would want.